Last time we were here, last release I did, I think, was all about Algol 60 and its 60th birthday. We left it in a situation, I think, where Algol 60, it was agreed by everybody, had been enormously influential. It was a rallying point for discussions and so on. There were aspects of it that some people didn't like, but it did set down a kind of benchmark of sorts. But you could legitimately then ask and say, well, all right, so where did high-level languages go after Algol 60? Was there on the Algol 60 committee oh heck, where do we go from here moment? Oh yes, there was. Some of you, I think, will know that an influential member on the Algol 60 committee, I mean, we've talked about Bacchus and Nauer, John Bacchus, Peter Nauer, Bacchus-Nauer notation, all that. They weren't the only people who managed to win the Turing ACM award just for what they did on the Algol 60 committee. Another person who benefited hugely, and rightly, was Niklaus Wirth. A lot of you will know all about him already. He was, on the Algol 60 committee, very respected computer scientist. He's from ETH, Elektrotechnische Hochschule, is it? In Zurich. And he and his big friend Tony Hoare, famous British computer scientist, were bedded into the Algol 60 committee. But Niklaus took the view, and it helped enormously, that although Algol 60 was what was democratically decided that they could do for Algol 60, he, Niklaus, would run as a sort of parallel project almost, his version of what he thought was a bit more sensible. So, for example, last time I just mentioned the horror of what can go wrong with call by name. So Niklaus was having none of that. And he came up with his own, as it were, sensible version of Algol, called Algol W, W for Wirth. And of course I must now tell the obligatory Niklaus Wirth joke. I don't know if this is true, but if it isn't true, it should be true. And it's a very gentle and well-meant joke, because he deserves a lot. He's been a very influential figure. So there we are in the late 60s. Anybody on the Algol 60 committee is getting endless invitations to talk about progress in program language design and what really goes on behind the scenes at the IFIP Algol 60 committee. And Niklaus was not beyond accepting some of these. And so the story goes that he gets invited to America, introduced, Herr Professor Dr. Niklaus Wirth and all that, from ETH in Zurich, and he stands up and says, I want to thank you all very much for inviting me here. It is a great honour. I should say that it puzzles me. Here I am in the United States of America. When I'm back in Europe, even the cloth-eared Brits try very hard with my name. They really try hard to say Niklaus Wirth. And they get it pretty well right. But over here, unfortunately, I'm forever being called Nicklesworth. Hand goes up from the audience and said, that's because Europeans call you by name, but Americans call you by value. And of course the whole place just collapses, It's absolutely in-joke of all in-jokes. But the Algol 60 committee did a grand job, but in the introspection of having released it, and it's been pretty successful. So where do we go from here? And I think the next stage was codenamed Algol X. A little subcommittee gets appointed, with perhaps led, I think, by Niklaus Wirth, I'm not sure. And of course the subcommittee came back and said the obvious route for Algol X is just to do Algol W, which is what it should have been all along. But there was a minority view which, I don't know, felt very strongly about it, led, I think, by the Free University in Amsterdam. They had, again, a very venerable and respected computer scientist called Adriaan van Wijngaarden. And he and his followers strongly believed that Algol X should take a giant leap forward and not just be concerned with tidying up the loose ends on what went wrong with Algol 60. And such was the level of full and frank exchange of opinions. I think Tony Hoare and Wirth and one or two others resigned in protest from Working Group 2.1, which was the committee that defined Algol 60. So that left behind a sort of rump of equal fanatics, but in a different direction. Very interesting direction. And they eventually progressed to what became known as Algol 68. The Algol W type sort of went off and did their own thing, and the result was a big success. It's called Pascal. We all know about Pascal. You can... It had a heavy take-up, I think, because compilers were available. Good computer scientists could take a look at it and say, yeah, I think I could implement that. It was a distillation, if you like, of all the bits you could safely include. And one of Pascal's strengths, but according to some also its weaknesses, was that it deliberately restricted you and kept things simple so that it was suitable as a teaching language. And it was very successful in that regard. No end of people in computing companies and universities thought, oh, I could write a Pascal compiler. It's not too bad. And it did make some important steps forwards. For example, that you can do records in Pascal. You can do pointers, but here's the start of trouble ahead. Basically, Wirth believed, and he's right, and it was echoed years later by James Gosling, pointers are dangerous. Pointers are some of the most dangerous things you can have in a program. Well, how do you cope with that danger? And the answer from Niklaus Wirth in Pascal is, you may have a pointer to something, but only at that one level. You can have a pointer to an integer, but you cannot have a pointer to an integer. That, fans, immediately prevents it from doing the triple ref trick. Because we talked about this a while ago. You can do very clever things in list processing if only you can handle pointers to pointers even. You just can't do that in Pascal. And in the correspondence that came along with that episode, I had people saying, oh, but my library can fill in for you. And if only you use extended Pascal, which wasn't agreed until about 10 years later, it works absolutely fine. Yes, but at the time, there were limits what it could do with pointers. The idea was that this is a language for beginners, and if you run out of steam, it's not too bad, because they'll go on to use more powerful languages later on, which in a way was fair enough. And there were dozens of compilers created between, I think it was announced in 1969, Pascal, and over the next decade, lots and lots and lots of compilers. Some of you will know that it even got onto micros via Z80s and things via UCSD Pascal, yeah? University of California at San Diego. So at the end of the 70s, a certain Brian Kernighan, who was well known to us, of course, and is well known to us, had been working long and hard in the Unix community at Bell Labs to convert what is called, of course, in Unix parlance, software tools. It's the bits and bobs that come with Unix, which are so valuable, you know, the sort functions, the grep, the bits and pieces that aren't literally in the kernel of the operating system. But it wouldn't be Unix if you didn't have all of these things going. And of course, a lot of people said, well, it's all right for you, you do it in this C and all that. We haven't got a C compiler. We like these tools. Can you do them in other languages? I think it went like that. And Brian's colleague, Bill Plauger, originally, I think, maybe both of them, did a thing called Software Tools in Fortran, because that was still a big, big deal in those early days. And then once that had been established, they actually got down and said, right, Pascal, very popular, let's do Software Tools in Pascal. When that task was complete at the end of the 70s, early 80s, Brian wrote a memo, which I'm glad to say is much less contentious than the infamous vacation memo about jailbreaking typesetters, but it caused a lot of discussion. And at the end of that paper, he comes up with 9 things that Pascal got wrong or ignored. It reminds those of us who remember Hitchhiker's Guide to the Galaxy, there is a philosopher in that series who allegedly wrote this tome called Where God Went Wrong. Well, all computer science can offer is Brian's list of 9 places where Pascal went wrong. And although the Pascal fans got very huffy about it, they had to admit he'd got a point. He knew what he was talking about. He wasn't just talking about teaching this language to a few kids where you could leave out the bits you didn't like and didn't understand. He'd actually done a considerable volume of work One or two of the things we could just pick out here that he pointed out was there is no way to declare a byte in your Pascal computer. You can't declare it as being of mode bits at all. You can't get down to the bit level manipulation. He said all I wanted to do was to exclusive OR one bit pattern with another, which you do all the time in cryptography, but I couldn't get down to the bit level. Just couldn't. And then somebody says, oh, but there's a library that will do it for you and it's in assembler. But that's not the point. The language itself won't let you do that. And so people fond of the language, first of all, went huffy about it. But then I have to say, well, you've got a ghost of a point there, I must admit. And from then on, it always amused me that it became almost like a thing, you know. My argument here does this, 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 and this, and it disposes of Kernighan's cases 2, 7, and 9, you see. So it became very famous in that regard. He basically was pointing out the pointers are bit brain dead, will only do level 1. It's not a real system implementation language because it can't do bits. It has no facilities for separate compilation. You can't do bits and pieces of the program separately and link them together afterwards. He said, essentially, it is fine. It is a teaching language. It does what it does well, and it gives you a protected environment which you cannot break out of. Once you run out of steam with it, there are no workarounds. None. Okay? So you have to move on to something else. 60 did do was give at the syntactic level and also at the implementation facilities level enough. Ken Thompson, faced with the problems of fonts on the 202, where individual characters shouldn't get too complex, you'll never guess how he did something like